आज ही डाउटनेट ऐप डाउनलोड करें। डाउटनेट पर होगा अब आपके सभी मैथ्स, केमिस्ट्री, फिजिक्स और बायोलॉजी डाउट्स का सफाया। बस अपने क्वेश्चन की फोटो खींचो, उसे क्रॉप करो और तुरंत वीडियो सोल्यूशन पाओ। डाउनलोड नाउ।
In this question, we need to determine limit x tending to 0 minus summation from r equals to 1 to 2n plus 1 greatest integer function of x to the power r plus n plus 1 divided by 1 plus greatest integer function of x plus mod x plus 2x, where n belongs to set of natural numbers and this denotes the greatest integer function. So our limit can be written as, let us denote it as some L. So L will be equals to limit x tending to 0 minus, I will open up the summation. So we will have, for r equals to 1 we will have greatest integer function of x, then for r equals to 2 we will have greatest integer function of x square. It will continue in the similar way. Then we will have x to the power 2n minus 1, then we will have x to the power 2n, and finally the last term will be equals to x to the power 2n plus 1, and then we have plus n plus 1, n plus 1, and in the denominator we have 1 plus greatest integer function of x plus mod x plus 2x. Now let us understand one thing, that x is tending to 0 minus. So the value of x will be less than 0 but very close to 0. So in that case, when x lies between minus 1 and 0, the value of greatest integer function of x, that is the greatest integer less than equals to x, will be equals to minus 1, and when x lies between minus 1 and 0, x square will lie between 0 and 1, and in that case the value of x square, greatest integer function of x square, will be equals to 0. Or we can also say that for all values of x power odd, we will have greatest integer function of x to the power odd as minus 1, and we have, when we have x to the power even, then in that case the greatest integer function will be equals to 0. So using this property we'll apply this here. So we will have L equals to, limit x tending to 0 minus, the greatest value of greatest integer function of x will be equals to minus 1. Now the value of greatest integer function of x square will be equals to 0. In the next bracket also we will have minus 1 plus 0 plus dot 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 till, for the value of x to the power 2n minus 1, we have a odd power here. So the value of this term will be equals to minus 1. And then we have an even power on x. So the value of this term will be equals to 0. And then we are left with x to the power 2n plus 1. X to the power 2n plus 1. And then we have plus n plus 1 divided by 1 plus greatest integer function of x plus mod x plus 2x. Now let us count that what are the total number of brackets here. Now note that here the power of x was from 1 to 2n. So there are total number of 2n terms, but since we are taking total 2 terms in a bracket, we will have a total of n brackets. So this value will be equals to, so L will be equals to, now here we have a total n brackets and the value of each bracket is equals to minus 1. So we have minus 1 repeated n times, that is the value of this whole term will be equals to minus 1 into n. Now I will apply the limit for the remaining terms. Now for this term, since we have a odd power here, so the value of limit extending to 0 minus greatest integer function of x to the power 2n plus 1 will be equals to minus 1, and then we have n plus 1 divided by, we have a typing error in the question. Here we will have greatest integer function of x square. So here also we will have x square, and here also we will have x square, and so the value of greatest integer function of x square as limit x tending to 0 minus will be equals to 0. So we will have 1 plus 0. Now I'll calculate this part separately. So we have limit x tending to 0 minus mod x plus 2x. Now since x is less than 0, mod x will open as minus of x, and then we have 2x this will be equals to limit x tending to 0 minus 2x minus x, that is x, and then this will be equals to 0. So in place of this I can write down 0. So the value of L will be equals to, in the numerator we have minus n minus 1, then plus n plus 1 divided by we have 1, and this will be equals to 0. So our required answer will be equals to 0.
क्लास 6 से 12 से लेके नीट, IIT, जेई मेंस और एडवांस के लेवल तक 10 मिलियन से ज़्यादा स्टूडेंट्स का भरोसा। आज ही डाउनलोड करें डाउटनेट ऐप या व्हाट्सएप कीजिए अपने डाउट्स 8400 400 400 पर।